Hi guys, good morning. In my previous videos already I have explained you about the real numbers. So if till now you have not subscribed my YouTube channel, kindly subscribe it. Today we'll directly discuss about the numerals on exercise 1.1. So moving to question number 1. Using Euclid's division algorithm, we have to find out the HCF. So now question number 1, 135 and 225 in bit I. So bit I, HCF, your 135 comma 225. So your Euclid's division algorithm tell us that A is equal to BQ plus R comma 0 less than equal to R less than B. This is your Euclid's division lemma. So now here we will see that A is equal to 225 comma B is equal to 135. Now we will divide 225 by 135. So 135 into 135, it is subtracted. Now 0 is coming 9. So now 225 is equal to 135 into 1 plus 90. Here remainder is not equal to 0. So we will continue the division. How? Now your divisor will be 135. It will be divided by the remainder 90. 91, 90. Now coming 45. Here also we will write 135 is equal to 90 into 1 plus 45. The remainder is not equal to 0. Again we will divide till we get the remainder 0. So now here 90 divided by 45 to 90 minus 0. Therefore 90 is equal to 45 into 2 plus 0. Here remainder is equal to 0. Thus HCF 135 comma 225 is equal to 45. As you know, where the remainder is 0, that divisor is the HCF. Now move on to the bit 2. In bit 2 we have 196. So same thing, we are getting A is equal to BQ plus R, 0 less than equal to R less than B. Here A is equal to 38220 comma B is equal to 196. So now here 38220 divided by 196. 196. So 12 minus 6, 6. Now here it is 17. 17 minus 9, 8. 2, 1, 1. So now again we'll drop 2. So 2, 18, 18, 9, 9, 81. So 9. 9, 6, 54, 4, take 5. 9, 9, 81 plus 5. 81 plus 5, 86. Now 8, 9, 1, 9 plus 8, 17. Now minus 12 minus 4, 8. Now 5 minus 5 becomes 15. 15 minus 6, 9. Now here again 0. So 0 means the 9 5 45 is coming 5. So it is coming 980. 0. Therefore 38220 is equal to 196 into 195 plus 0. Here remainder is equal to 0. Hence HCF 196, 38220 is equal to 196. So 196 is a factor of 38,220. Now move on to the bit 3. Move on to the bit 3. Here bit 3. Same formula, A is equal to BQ plus R, 0 less than equal to R less than B. Here A is equal to how much? 867, B is equal to 255. Dividing 867 by 255. So 8, 3, 3, 5, 15, 5. Take 1, 3, 15, 6. Take 1, 7. So minus. So here is 2. Now it is coming 0, is coming 1. Now we can write 867 is equal to 255 into 3 plus 102. Here the remainder is not equal to 0. So we'll continue the division. How? Now 255 is the dividend, 102 is the divisor, 204 minus the coming 1 5. So here also remainder is not 0. So 255 is equal to 102 into 2 plus 51. The remainder is not equal to 0. We will continue division. So here again we will divide 102 divided by 51 to 102. Here remainder is 0. So 102 is equal to 51 into 2 plus 0. Remainder is equal to 0. Hence, HCF your 867, 255 is equal to 51. This is the answer. So we will move on to the question number 2. So question number 2, so that any positive integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where key is some integers. So our A is equal to BQ plus R. Let two numbers are A and 6. A and 6. So if B is equal to 6, then R less than less than 6. So R is equal to 0, 1, 2, 3, 4 and 5. So R less than 6. 0 less than equal to R less than 6. So now putting this, if R is equal to 0, then A is equal to 6q is equal to 2 into 3q, as it is multiplied by 2. So 2 is a factor of 6q, hence 6q is an even number. Now come to when R is equal to 1, then A is equal to 6q plus 1 is equal to 2 into 3q plus 1. 2 into 3q is odd number. 2 into 3q is even number. Even number plus 1 will be an odd number. Odd number will be an odd number. Now R is equal to 2, then A is equal to 6 cube plus 2, that equal to 2 common 3 cube plus 1. So 2 is multiplied, whatever in the bracket may be, 2 is multiplied. So as 2 is a factor, it is even. Now r is equal to 3, then a is equal to 6 cube plus 3 is equal to 3 into 2 cube plus 1. 3 is a factor, but 2 is not a factor. Hence 6 cube plus 3 is an odd number. Now r is equal to 4. Then a is equal to 6 cube plus 4 is equal to 2 into 3 cube plus 2. It is even as 2 is a factor. Now r is equal to 5. Then a is equal to 6 cube plus 5 is equal to 2 into 3 cube plus 5. So 2 into 3 cube plus 5 as, or we can write is equal to 2 into 3 cube plus 4 plus 1 is equal to 6 cube plus 4 plus 1 is equal to 2 into 3 cube plus 2 plus 1. This is your 2 into 3 cube plus 2 is even. So even number plus 1 is equal to an odd number. Thus 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5 are odd integers for Q is some integer. Now check it. So when b is 6, so r must be less than 6 or r equal to 0. So when putting r is equal to 0, we are getting an even number. When putting 1, getting odd number. 2, 6 cube plus 2, even number. 6 plus 3, odd number. 6 cube plus 4, even number. 6 cube plus 5, odd number. So 6 cube plus 1, 6 cube plus 1, what we are getting? An odd number. 6 cube plus 3, 6 cube plus 3, what we are getting? An odd number. 6 cube plus 5, what we are getting? An odd number. So now we will move to the next question, question number 3. Now come to question number 3. An army contingent of 616 members is to march behind an army band of 32 members in parade. So the two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So here we have to find out. We have to find out the HCF of 616 and 32 using Euclid's division lemma. As we are going to find out what? Maximum number of columns. Maximum number of columns. So now 616 divided by 32, 132 2. It is coming 9, 29, now 6, 32. Well, finding it 32 into how much? 9, 8, 8, 1, 28. Now minus 16 minus 8, 8. Now, so here 616 is equal to 32 into 19 plus 8, where r is not equal to 0. Now again we have to divide 32 divided by 8. 8 4s are 32. So here 0. Now 32 is equal to 8 into 4 plus 0. So r is equal to 0. Hence, the HCF 616, 32 is how much? 8. Thus, what is the maximum number of columns in which they can march? Thus, they can march in 8 columns maximum. This is your answer. Now move to the next. Question number 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer n. Now we know Euclid's division lemma. A is equal to BQ plus R. So now let our two integers are A and 3. So here B is equal to 3. Then R will be 0, 1 or 2. So R less than B. R less than B. Now A is equal to how much? So 3Q. A is equal to 3Q. Now A square is equal to 3Q whole square is equal to 9Q square is equal to 3 into 3Q square. Let's say is equal to 3m. Let's say m is equal to 3Q square. Let m some integer. So Q square, Q is an integer, Q square is also an integer. 3Q square is also an integer. Why? Q square is also an integer, 3Q square is also an integer, Q is an integer. So now 3Q square integer and Q square integer, 3Q square integer. Now let's say A is equal to, here R is equal to 0, R is equal to 0, here R is equal to 1, R is equal to 1. So A is equal to 3Q plus 1. Now A square is equal to 3Q plus 1 whole square is equal to 9Q square plus 6Q plus 1. That is equal to 3 taking common 3Q square plus 2Q plus 1. So that is equal to 3m plus 1. Now let m is equal to 3Q square plus 2Q 2q. Let m is equal to this, say, because m is any integer. So when q is any integer, this is also an integer, plus 1 is also an integer. Now come to the third case. R is equal to 2. So a is equal to 3q plus 2. Now a square is equal to 3q plus 2 whole square is equal to 9q square plus 3 to the 6 to the 12q plus 4. So that is equal to now 9q square plus 12q plus 3 plus 1 breaking 4, 3 plus 1 is equal to 3 taking common, 3q square plus 4q plus 1 is equal to 3m plus 1. So here also m any integer, q is any integer, so this is one integer plus 1. Therefore, so 3m or 3m plus 1, 3m or 3m plus 1. Here we are coming 3m, here we are getting what? 3m plus 1, here we are getting 3m plus 1. So 3m or 3m plus 1 is the square of any positive integer, is the form of square of any positive integer. So I hope pause it down and note it down. Pause the video, note it down. Before we moving to the next question, the last question of this exercise, question number 5. Please share, subscribe and like my videos. Give your valuable comments. Now move to the question number 5. Come to the last question. The same question like it's question number 4. So here Euclid distribution lemma A is equal to BQ plus R, comma 0 less than equal to R less than B. We know this one. So here you will take A is equal A and 9. So 9m plus 1, 9m plus 8 is given. So we can take A and 9. But if we take A and 9, so it will be lengthy because finally R will be your less than 9. So when R will be 8, then we'll find the cube, 8 cube. So it will be difficult. So we'll try it alternatively in different way. Let us see how we are trying it without taking 9. We'll take it as b is equal to 3. So now when b is equal to 3, my r less than 3. R is equal to 0, 1, 2. So now let cases are there. A is equal to bq plus r. So now R is equal to 0. Now A is equal to, so I have taken B is equal to 3. So A is equal to 3q. So A cube is equal to 3q whole cube is equal to 27q cube is equal to 9 into 3 q cube is equal to 9m. Let's say m is equal to 3q cube. As q is an integer, q is also an integer. Hence 3q is also an integer. Now r is equal to 1. So that implies a is equal to 3q plus 1. So aq is equal to 3q plus 1 whole cube is equal to a plus b whole cube. A cube plus 3 square b plus 3 ab square plus b cube. So a cube 27 q cube plus 3 3s are 9 3s are 27 q square plus 3 3s are 9 q plus 1. So now that is equal to 9 taken common, 9 3q cube plus 3q square plus q plus 1, that is equal to 9m plus 1. Let's say m is equal to 3q cube plus 3q square plus q. So similarly, as q is an integer, q is also an integer, 3q integer, 3q square integer, q is integer. So this total is an integer. This total is an integer as q is an integer. Now come to the third one case. R is equal to 3. That implies a is equal to, so sorry, it is 2, not 3. So 3q plus 2. Now aq is equal to 3q plus 2 whole cube is equal to same, a plus b whole cube is equal to a cube plus 3 square b plus 3 ab square plus b cube. So this is 27 q cube plus, sorry, yes, plus 9 3 27 54 q square plus 9 4 is 36 q plus 8 plus 8. So that is equal to 9 taken common, 9 3q cube plus 6 q square plus 4q plus 8 is equal to 9m plus 8. Let's say m is equal to how much? 3q cube plus 6q square plus 4q. Now q is an integer, so q is an integer, q square integer, q integer, so entire is an integer. Thus, hence, the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. 9m plus 1 or 9m plus 8. So thanks for watching my videos till now. In my next video I'll upload exercise 1.2. If at all you have any doubt, give a comment in my videos. Thank you all.